welcome back, and we are still running flat out to try and get what I've been calling the CPU 46 up and running in time for VCF East in New Jersey, which is coming up frighteningly fast. Now I'm calling it the CPU 46 because it's a CPU 4 sized cabinet, but it's going to have CPU 6 internals. And as far as I know, Centurion never built a CPU 6 in that size of cabinet. They very quickly changed to this size of cabinet that could fit 2 Hawk drives in it. So it's kind of a weird amalgamation of build styles, but I think it's going to be faithful enough to really sell the whole Centurion experience. But in order to sell that experience, we need to get the Hawk drive going. And where we left off in the previous episode, we were in a bit of a bind because of the 4 heads in there, 3 of them measured with open coils. And now I may be crazy, but I am not crazy enough to take my only working Hawk with me. So I absolutely have to get that drive going. But that raises a couple of questions that you guys had in the previous episode. There was a ton of amazing comments, and a lot of them were really pertinent questions, and I want to answer just a few of them. And the first was that, did I measure the actual wires on the heads when I measured whether the coils were open or not? And I totally get where you're coming from. Those wires are under a lot of stress. They move back and forth a lot. There's a lot of movement in there that could cause an internal break within a wire that would look like an open coil. But that was one of the first things I did. I was really hoping for an easy fix, and I'm not that lucky. It's just a bad coil, I'm afraid. Now, I did get some fantastic high-resolution macro shots of one of the coils, and you can see that all of the coil wires are definitely soldered in place, and I might go through and reflow those just to see. Maybe there's a broken connection there that I can't see in the macro shot, but it's incredibly tiny. The coil wires are so small I can't see them with my naked eye. I have to get a macro lens on it. So I really need a microscope before I do any more work on these heads. And I think there is a possibility that even if there is an open coil in there, we can rewind these. Looking at the construction, it's not impossible. It'll be tedious and very difficult, but I think there's a possibility there to bring 3 of those heads back to life, maybe. Now, the next question was, why did they go open in the first place? Because we don't want to put new heads back into the system and have it potentially just blow those heads wide open as well. And so there's 2 schools of thought that I'm having on this. The first is just corrosion on the coils. They're not totally sealed or potted in anything. They're pretty exposed, and we've seen that on the FFC card there was already water damage, the same on the memory card that came in the counterfeit system, and these heads came out of one of the counterfeit Hawk drives. So corrosion in a damp environment could definitely cause that problem. But also, when we were first powering that Hawk drive up, I don't know which power supply was in it. I have 3 Hawk drives, which means I have triplicate of everything. And this Hawk drive is full of nothing but good parts, so that leaves me with 2 power supplies. And one of those power supplies has a completely fried power transistor on it. I mean, it's scorched. And it's possible that that power supply was in the system the first time we spun it up and we just didn't know that it was bad. And that could have put an extreme amount of voltage or current through the heads and popped some of the coils. But that supply is not in there at the moment. And as far as I can tell, that's the only thing electrically that could have caused the coils to go open like that. So we've got a good supply in there right now, so any new heads that we put in there shouldn't go open. And finally, the biggest question, the biggest comment that I got was, why don't I just emulate the drive? And well, I've got 2 answers to this. The first is that that's really hard to do. The Centurion uses a very strange way of dealing with data because it was meant to be used with, it was meant to be backwards compatible with the old lit and tape systems. So it's 400 bytes per sector as opposed to the standard 512 bytes per sector. And then it's hard sectored to 16 sectors per track, and then there's 410 tracks per side, and then 2 sides, so 820 tracks total or something like that. But the controller cards are expecting that data to leave the card and come back into the card in a very specific way. Particularly with the Hawk, there's a 2.5 megahertz bit clock that's kind of governing everything, and then the data is interspersed with that. So we have to figure out how to program an emulator to handle such a high-speed bit clock, pull all of that data apart, store the data somewhere, retrieve it at a moment's notice, and supply it back to the CPU without getting too slow to upset the watchdog timers in the computer. Now, we are working also on a floppy emulator because that's a little bit more of a standard interface, but again, there's still a lot of hurdles to overcome with that. So we are actively working on an emulator. I don't know if it'll be ready in time for VCF though. However, the bigger problem with that is that the Hawk drive is part of the Centurion experience to me. That's just part of the whole act of using this machine, is hearing that jet engine spin up. And every time you type a command, you feel the whole cabinet shake as it's seeking all over the place and moving probably about a pound worth of metal back and forth. I mean, it's just part of this, the experience. That's what I want people to experience when they're at VCF. I want people to feel this, to hear it. It just is an assault on the senses. And so I think it's really important that we get one of the Hawk drives going. So I really need to do some work on that one. Now we have 3 bad heads, and I'm not going to be able to repair those before VCF, but we have 3 good heads as well. One of them was one of the ones that originally came out of that system. We know it flies. We're going to reuse that one. The other 2 came out of that Hawk drive, which was the oldest Hawk drive that we had that had a wicked bad head crash on it. However, they ohm out good. So we're in a position now where we really need to clean those up. So I'm going to take the one that I need to make a single platter Hawk, because we can essentially just build this into a 5 megabyte drive. There's no need to have that removable platter up there other than redundancy, but we can just build this into a single platter Hawk using 2 heads only, and I just so happen to have 2 good heads. But we got to clean one of them up. So it's time to get to work cleaning up one of those heads, get it into the system, spin it up, and hopefully we can format it and start getting an operating system onto it. So let's get to work. Now we're going to try and do something that I don't think anyone has ever done before. We're going to try and build a single platter Hawk drive. And in order to do that, well, we need to get all the heads out first so we can get new heads back in it, which means that we got to take the entire thing completely apart, take the platter off, store it someplace safe, so that way we can get easy access to the heads, remove them, and try to figure out what we're going to do for putting new heads back into the fixed platter. Now, new is in as many quotation marks as you can there because there are no more new heads for this drive. But we have 3 heads that measure out fine as far as the coils go. One of them was in there already and we know it flies, so we're not even going to mess with it. It's the lower head that I'm worried about, and I only have one more option for it, and that's the lower head that came off of the really heavily crashed drive, and it is in very rough shape. So I need to clean it up a lot. And in order to do this, I'm going to use 1980 spec green bar printer paper because the weave of the paper is a little coarser and I think it'll do a better job of lapping the surface of the head here. And so I'm just going to soak it in alcohol and get to work. And this is a long, arduous process, but after a lot of scrubbing, I think this is gonna work. The leading edge looks a little frightening and there's a lot of scratches down it, but as long as it's smooth, as long as nothing's protruding, it should fly. So let's go ahead and get these 2 heads back onto the fixed position. And it's a little fiddly because of the spring pressure, but once they're in place, we'll go ahead and lock them down with the locking nuts here. And I'm going to try and make sure that the heads are centered up decently well. And then we'll go ahead and very carefully set the platter back in place. We'll put the locking ring around it and we'll cinch it down with these 6 bolts that hold it nice and tight. Then we'll put the enclosure around it, and now we need to do something with the removable platter because the internal Hawk circuitry actually runs a check on the sector pulses coming from the removable platter to make sure that you're not trying to spin the drive up without a removable platter installed, which is actually exactly what we're trying to do. So we need to fake out the Hawk control boards so it'll actually spin the drive up and let us use that. And so I'm going to rebuild the removable platter only without a platter in it. It's just the sectoring ring. Now I could take that sectoring ring and just put it directly on the magnet, but I would would never be able to pry it back off of that magnet. So by building up the removable platter case, I can now remove the removable platter magnet off of it. But with that all built up, it's time to give this thing a shot. All right, here we go, single platter hawk. I've got the heads on the fixed platter installed and locked down. The alignment on them doesn't matter because we're just gonna do a dot format one if it works. There's no heads on the top, so it looks looks a little funny. All that's it's waiting on now is for me to plug the heads in, spin it up, and see if it comes apart. If it does load the heads and it doesn't sound like the end of the world, we'll bump over and we'll try to do a dot format one. And if the format one passes, fantastic news. If the format one fails or if the heads crash, we're kind of in a rough spot then, but let's hope for the best on this one. So I'm gonna plug the heads in, spin this thing up, and oh man, I hope it goes well. I genuinely don't know what's gonna happen here. And this is the longest wait of my life. It's 50 seconds after spinning up to see if the heads will load. So, oh, come on, please load, please load. Ah, they loaded, and I don't hear anything bad. It doesn't sound like they crashed, so they should be flying. That's amazing. That's excellent news. Let's try to run a format. So I'm gonna run over here and I'm gonna type dot format one, and that's, well, it's different, but that's still not good. Bad track 0. That's, oh man, we still got a problem here. As you saw, it loaded the heads and they flew without crashing. That's fantastic news. And when the heads are all the way retracted, I can kind of peer in and see the fixed platter down there, and there's no marks on it at all. So it definitely didn't crash. But, you know, 2 steps forward, 1 step back, our format command failed. And this started the next 8 days of troubleshooting hell for me. I was going at this thing with the assumption that the heads were good, but something else was wrong. And so I took countless scope shots, and actually I took too many. I just checked every input and output out of all of the major cards on there, and well, the problem is clearly visible in one of these scope shots. I just didn't catch it. As a matter of fact, I got to the point where I was looking at too many scope shots. I was struggling with the hardware so much, I was starting to burn myself out. So I took a little break and I wrote an assembly program to hopefully help with this troubleshooting procedure. And that's what we took a look at in the previous episode. It's just a simple little loop that does a format write of a sector, then reads it back, checks the status register, and then depending on what bit is set in that status register, it tells me whether the read was successful or not. If it was a successful read, it prints a dot. If it's an unsuccessful read, it prints a letter to tell me what it was. F is for format error, S is for sector address error, C is for a CRC redundancy check error, and T is a timeout error. If the heads are disconnected, I get timeout errors. That makes sense. But I'm getting nothing but format errors with the occasional sector address error. But I think the sector address error is a fluke. And so nonstop format errors is really indicative of a bad head, but I'm not removing those heads again. They have to be good. I have no other options. So let's just keep plugging away at it. And so with my program, I was able to spin the drive up and let it run over and over and over again and do more probing and do more scope checking and things like that. And finally, I was talking to Ken Romaine and he said, hey, do a sanity check. You should have done this first, but do a sanity check for me and plug the heads into the removable plugs on the read-write erase card, because that eliminates a huge amount of circuitry. And I did that, ran my little test program again, and dots. We're getting successful writes and successful reads back for both upper and lower heads. And that's amazing. That means the heads are good. That means that this is going to VCF. But why did it only work on the removable and not on the fixed? Well, earlier I said that the answer was there clear as day in one of the scope shots, and it's the scope shot of the sector pulses that are being sent to the operating system. One rotation of the platter takes 25 milliseconds. There should be 16 sector pulses in there. But if we count the time between sector pulses on this scope shot, it's about 390 microseconds. And well, if you do all of the addition for that, that comes out to 64 sector pulses per rotation finding their way into the operating system. That is way too many. And it turns out there's nothing broken, I just had it set up wrong. The sector card in there has a divisor on it. Because this thing is hard sectored, it can send any number of sector pulses that you want. It just starts at 64 and then you divide it down to whatever your system is using. So I had it set to divide by 1. Should have had it set to divide by 4. So I just flipped that little dip switch, plugged it in, ran my program again. There we go. Dots. Perfect writes, perfect reads. It's working fully. And yes, that's one of the dumbest mistakes I've ever made, but it wasn't a catastrophic mistake. It was a great learning experience, and I don't care because it works. The whole thing works now. All we got to do is start getting real data onto it. So that's the next step. And I genuinely don't know how this is going to go, but we're going to try and get an operating system onto it and booting from it. And if it boots, the next step is to pull the card cage out, get it in there, and turn this into a self-contained Centurion all unto itself. I'm so excited and so relieved that the heads are working. Just absolutely amazing. Let's get to work. I want software on this thing. All right, it's been a few hours. Of course, nothing goes as planned when you're doing this. The floppy drive, you may notice, is no longer in the mini Centurion. It's here on the floor, and that's because it just absolutely refused to work. I think what happened is the clamp on the stepper motor had loosened up given how hard the OS hits the floppy through all the vibration, as well as me just moving it around and handling it. And that allowed the stepper motor to rotate, which just put everything completely out of alignment. And I don't have an alignment disc or anything like that to get it back into alignment. So I got it mostly working again and just hooked it up to the genuine system over there and copied a bunch of files back over to it. And so now we've successfully booted into the operating system off of the floppy. I say successfully, it took 2 tries to boot. For some reason, the first time it halted the CPU with no error messages. So I have no idea how this is gonna go, but for right now, we're in the OS, and I think it's time to spin the Hawk drive up and see if we can run the new disk utility on our single platter Hawk. Hopefully it goes well and we can start dumping files onto the Hawk, because as soon as I can boot off of this, I'm no longer reliant on that for running the operating system, and things should go much smoother. So, well, here goes nothing. First things first, let's run a quick status check just to make sure that everything looks copacetic here. And actually, that's interesting. The fixed platter shows as formatted. That's from my format test program. So that's actually good news. We need to set the default drive to the floppy. That's what the .setadd=2 is. Then we'll run the new disk utility. And the drive is guarded. And oh man, I forgot to copy s.con, which is the cleanup utility that pretty much everything uses, to the floppy. And so without that, I end up in this endless error loop. I can force quit out of it with a Control-C, which gets me back to a CRT0 ready, but every subsequent action I take from here on out will end up in this same error loop. I think I can still battle my way through it though, but we will have to run everything with just pure JCL commands just to be safe. So instead of snewdisk, I'll run a .format1, and this is going to take a little while, but the drive is actually moving and seeking like it's supposed to. And well, the error loop popping up here makes it look like it finished properly. So next we essentially need to do the full new disk routine using JCL commands only, which is totally possible. And once the disk is prepared, we can start copying the operating system files from the floppy over to the Hawk. And the floppy is just painfully slow during this copy. But interestingly, it's about 3 times faster copying from the floppy to the hawk than it is copying from the hawk to the floppy. I don't really know why that is, but I'm grateful for it here. All right, that was interesting. Without the SCON utility, I don't know if anything finished appropriately like it was supposed to, but I believe I've copied the operating system onto the Hawk drive, so we're gonna try and boot from the Hawk drive for the very first time. I'm gonna push the RF switch here. That's gonna tell it to boot from the fixed. I'm gonna hit the OpSys button here. That's gonna reset us back to the D equals prompt. And then I'm gonna type H1. It should do 3 RTZs and then hopefully load the OS. It did the 3 RTZs. It looks like it's loading. I think that's it. Hang on a sec. 082384. Come on, get us into the OS. CRT0 ready. Do a status. There we go. Number 1, Usagi. We just booted the operating system off of this Hawk drive. This Hawk drive is running the OS on that machine. It works. It works. Unbelievable. Oh man. Whew. Well, the operating system is also completely useless at the moment because there's no utilities on there at all. If we do a directory listing of that drive, we'll see that it's just the basics. It's just @load, @osn, and @sys, but we have 757 tracks available, so let's start dumping some stuff in there. I've got a boatload of floppies with the entire S folder, the entire question mark folder, also the entire P folder so we can assemble and create new things, and that should get this drive pretty much up to the same point as that drive, which will be the second time I've said this, but I think it's gonna work this time. This is really exciting, but it's gonna take forever copying stuff from the floppies, so I'm gonna get comfortable and just keep swapping floppies in while the files copy over. This is awesome. Interestingly, while it's copying, we can see the floppy loading and unloading the heads and seeking back and forth, but even cooler than that, we can see how the Hawk handles a copy. It's constantly seeking back to track 0 to hit the bad sector list, and then it checks the directory listing so it knows where to write. Then it seeks out to the location where it's actually going to write data, and it writes the data in that location, and then it jumps back to track 0 to check the bad sector list for the next sector it's going to write, and the process just repeats. That's really cool to actually physically see that. But there's still a lot more copying to go, so it's mostly just a lot of sitting Seiza style and waiting for things to complete. There we go! Everything has been copied over to this drive. It is booted off of this drive. Every single utility is there. The entire S folder, the entire P folder, the entire question mark folder. It is a fully functioning Hawk-based Centurion, and it's the second one running in this room. How cool is that? I started this episode not knowing if it would come back to life, and here we are, working operating system on it. That is so cool. Now, before I wrap this up, there's one more thing I want to do. I want to take the card cage out of here, get it in here so that this is a self-contained system. Then spin it back up, boot back into the operating system, and see how it goes. So we still got a little more work to do, but I think it's going to be epic to have this be just one system on its own that can roll around. Oh, this is so cool. I'm so happy. This episode's going way better than I expected. We'll start by disconnecting everything, and then we'll slide all of the cards out. And next, let's get the CRT, or the data terminal, out of the way here. And once we have that, let's get around to the back of it and undo the screws holding the PSU in place so we can fold it down flat. And then we need to disconnect all of the wiring that goes to the backplane, and that'll allow us to get the power supply board here completely out of the way. And next we'll slide the drive tray out to give me full access to the card cage itself, which can now be lifted right out. And we'll follow that up by pulling the front panel out. These are all of the pieces that we need. So now let's start putting things back together, starting with getting the card cage into the new rack. And once in place, we'll cinch it down nice and tight. And next, I think I want to use the power supply as it is, just laid flat on the bottom like this. But it does need some trimming, and because I'm lazy, I'm not actually going to remove anything off of the board. I'm just going to slice it up from here. And I also need to cut out little corners so it can slide into place, and I'll use the bandsaw for that. And with it all trimmed up, it does slide right into place, nice and neat. And then I'll use a little L bracket to connect it to the rack rails and hold the back half of the board in place. And I also made some custom brackets for the front of the board, and now this thing is very solidly in place. And then finally, we'll get the front panel for the Hawk drive in place, as well as the front control panel temporarily mounted above it. There we have it, fully self-contained Centurion. It's on, it boots, it works, oh man, it's going to VCF, baby, and I couldn't be more happy. I think it's gonna be epic. I think people are gonna love seeing the actual Hawk drive at the show. Now, it's not going exactly like this. This is a little janky at the moment. It needs a ton of cable management, and I think I'm gonna have to make some new ribbon cables that are the appropriate lengths. It needs cooling fans on the card cage down here. It needs a ton of wood thrown at it, particularly the wood for the side trim pieces here and the top piece here. This front panel needs to be made out of metal at the proper size and shape. And I gotta figure out something for the side panels. Now I have plans for all of that, but it's gonna take me a little while to hunt down all of the pieces. So the next episode isn't going to be about this. As a matter of fact, it's probably going to be a few episodes before we get back to this, because I'm going to spend the next month really making it look good. But I want to thank you guys so much for watching and joining me on this journey. And I really hope you hang out for the next episode, because we're getting into some pretty exciting PDP-11 stuff on that one. So thank you so much, and I hope to see you then.